Kaylin, this is 1/6. That's the homework assignment for this. I think maybe you wrote that down already. We're talking about trig functions. Specifically, trig functions that are like sine and cosine and tangent. Trig functions.
No.
Trig functions. Sine, cosine, and tangent.
So does that mean we're done with the holes in the bonds?
No.
Oh.
Now we have to do it with
Not
a circle thing, apparently.
Yeah.
No, they're way.
Okay. Sine, cosine, and tangent. All right. We're going to back up a little ways because some of you guys haven't had trig yet. So here we go. The graph of sine, we've already kind of alluded to this. The graph of sine, my trig kids, does sine start at 0 or 1?
0.
0. He starts like this and he goes like this forever.
Why?
That's what sine looks like.
Why?
That's what the graph of sine looks like. And he goes forever to the left and to the right. Yes, sir.
Why is that up on the board?
What? I don't know.
Does it stay?
I'll
does
write him
it
down for you
go,
here in a second.
um,
He goes on forever. This way, oop, and he stays oscillating. He oscillates forever. And he goes forever in both directions. Okay, cosine is the same thing except he starts at 1 and he goes down and he comes up and he goes down and he comes up and he goes down and he comes up. Like that ish. So he starts at 1, but he's still going to oscillate just the same as what sine does.
Why does
Why?
that? Why? Yeah.
Why?
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 I know. That's just where he starts.
Why? Why?
Because cosine of 0 is 1 and sine of 0 is 0.
Why?
Okay,
Why?
sorry.
Why?
Yep.
Yeah, why?
All right, tangent. This is what tangent looks like.
What is this?
Tangent, I'm going to do this. Tangent, I'm going to do this. Tangent has a vertical asymptote at, do you guys remember?
-1,
No.
What? No. It's something.
Pi over 2 and negative pi over 2.
Yeah.
And he goes like this. And then he does that again. He keeps doing that. Pi over 2 and negative pi over 2, that's where he, his vertical asymptotes are. That looks what tangent looks like. Tangent looks altogether very different. That's what tangent is. Okay? So out of those, if we're looking just at normal sine, normal cosine, normal tangent, sine is
Our boss.
continuous or not continuous? Continuous. Cosine is continuous or not continuous?
Continuous.
Continuous. Tangent is continuous or not continuous?
Non-continuous.
Not continuous. Okay? Because he has vowels. Alright?
But
So, generally speaking, sine and cosine are continuous, tangent is not. Because he has vowels. Okay? Alright? Now, here's the deal. Let's look at sine and let's talk about some limits here. So let's say the limit as x goes to infinity of sine and the limit as x goes to infinity, negative infinity of sine.
why?
We'll say sine of x. Let's look at the limits. So what I'm asking for on that is as he goes forever to the right, what is sine approaching?
Infinity.
No.
No.
As you go to the right,
Sine is going forever to the right.
it's going
No,
forever. to
it
the
doesn't
right.
depend on the amplitude. If he's going forever to the right, sine does go forever to the right. What's he approaching?
Positive infinity.
No.
No, positive.
He doesn't go up forever.
Okay,
He just
positive
keeps doing this.
Zero. Or like it goes,
Nope.
it goes up and down, but like.
No.
But he never gets smaller towards,
Yeah.
you
So
know.
it's just-
He's gonna
is it
oscillate
zero-
forever
is it like
between negative 1 and positive 1.
In between.
Infinity.
The value.
Is it,
So negative
is it
one,
like
positive one.
Positive. Is it like two numbers?
What's the limit?
Oh, limits. Positive 1 and negative 1 or whatever.
Okay, so some of the
No,
time
but
it's
x is
approaching
greater
1, some of the
than or
time it's
equal to.
approaching negative 1. They don't,
Can you put-
they're not consistent with each other.
Can you put x's
They contradict one
Number-
another.
greater than x?
That it does not exist. The limit, it's not going toward one specific value because it's oscillating, right? Between negative 1 and positive 1. So some of the time it's going to negative 1, some of the time it's going to positive 1. It does not exist.
Same
On the
with
left
cosine.
side,
Oh, going negative, same thing.
does not exist. What about cosine?
Same thing.
Limit as x goes toward infinity of cosine of x. The limit as x goes toward infinity of negative infinity of cosine of x. Does not exist. Does not exist. Does not exist. All right, what about tangent?
Like if tangent goes to x? Like
No, if tangent
of
goes
x?
to infinity. Well, it just big positive infinity, right?
I kind of wonder how they would do that. They don't ask us this, but yeah, like
Other
Of what?
breaks.
What'd you
for
say?
tangent, as he
It
goes
would be
forever to the
positive
right, do you think
infinity.
it'd be positive infinity?
On the
No,
right,
because
on the
it
left
stops.
would be negative infinity.
Well, but it
But
doesn't.
it stops. It does
Where
it
does
keep
it stop?
going to infinity?
Where does it stop?
Vertical
It doesn't stop.
Yeah, it like keeps having vertical asymptotes in between.
But still
Can we
goes
figure
up.
that out?
But like on that one,
It still goes up.
I'm just thinking about that one. That's
It
why I
gets
said.
added.
Like that one doesn't have. Did they ask that? I
Just
don't know.
the right
That's a good question to ask. I don't know. I don't know the answer to that. As the limit as tangent goes to infinity, or as x goes to infinity for tangent, I have no idea. They don't.
Because it's not like
Yeah, 'cause it's not
continuously going. It's like
continuously-
having it's having like little breaks
Yeah.
where like the
Yeah.
bars are.
I would,
Does the
I
line
would,
start?
I would venture to say does not exist on tangent as well, just because he has those vertical asymptotes that separate him.
Well, you can't.
I don't know. I'm gonna put a question mark by him. The limit as x goes to plus minus. I'll look that up. How about that?
Yeah.
I don't know.
Where do you look it up at?
I don't know.
Google?
I'm gonna Google it maybe. Okay. So there's that. That is as he approaches infinity and negative infinity. These are infinite limits. Infinite limits. And infinite limits is asking on the right side and on the left side. What is he doing? Now in example 1, they're going to ask for a limit at a certain value. So I understand that the limit as x goes to infinity of cosine is not going to approach a value. It's going to be does not exist. But here they're saying as it gets closer to 1, what's it going to be, right? What's the value? Okay, I cannot plug 1 into that. I can't plug 1 into that, but what can I do? Can you break the top down?
Isn't it a hole?
Yeah.
No,
Yeah.
the hole you can remove. Like you can cancel it.
X plus 1, x minus 1. Now we're gonna
Oh,
remove the hole, right?
The hole and the bar.
No, there is not a hole in the ba. Because the
because
ba,
we took the
ba would be on the
bar.
bottom. Yep, ba would be on the bottom. So now we've gotten rid of him. Now I'm going to evaluate the limit as x goes to 1 of cosine of x plus 1. Now can I plug 0? Now can I plug 1 in? Sure. What's that going to be? Cosine of 2, whatever cosine of 2 is. Okay? Now, cosine of 2 can have two different values if you type it into your calculator. It depends on if you are in radians, which is in units of pi, or in degrees, which is in units of degrees. Okay?
Wait.
You guys know how to switch back and forth.
Is it on mode?
Mode.
Load something.
Okay?
Those are the dumb ones.
So for
I had to do
cosine.
Scientific notation too.
What?
That helped on my physics test.
On the dumb ones?
I have to go back.
You can switch them on the dumb ones.
Oh my gosh.
Alright, Chloe, can you catch me up to speed? I have to go back.
So you see D, that means you're in degrees. Okay, so you go to mode, and you go to,
Mode. Oh, that's math. Just kidding. Do we want degree or do we want radians? Or do we want
Chloe?
both?
Oh, I got it.
We can only be in one.
Yeah.
Both the time and trig are in degrees. Other than for like 2 lessons.
I want.
So do you want the 2D3 that fills around?
This is alpha. No, they're alpha.
Wow.
I know, it's just.
I don't know.
Yeah, did you forget about the FBLA?
That's today.
During.
I'm still like by myself.
Okay, actually, Chloe, actually, bathroom, can you catch me up to
Dylan
speed?
and oh, and Josh.
Yeah.
I don't think we do. I mean,
They should have said something yesterday.
I thought my car just got hacked.
I'm pretty sure Jake's
I just
on
got a
his side.
notification that $93 was spent on my car, so I texted Rachel, and I was like, $93 was just spent on my car at Under Armour. And she was like, I'm so sorry, it was me, I clicked on the wrong card. I about crapped my pants.
You might have to type in like cosine 2, enter, and then you would go shift radians. It's in radians.
Okay.
Okay.
Even though it's always E on the top.
Maybe. Yeah.
I don't think so, it's real.
Let's see. You're in degree? Okay, give me cosine of 2 in degrees.
Okay, well, we're gonna get
And
it.
degrees?
Yep, what's cosine of 2?
Are we
Cosine
doing
two.
radians or degrees?
Point 9993908.
0.99930
390.
something. 390.
827.
That's what it is in degrees?
Yeah.
Okay. Because it goes between 1 and negative 1. I guess that makes sense. Okay. What about radians?
Negative 0.416.
Negative 0.4165.
1.5.
Say it again.
Negative 4. 416.
0.41. 6, 1, 4, blah, 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 blah.
Blah, blah, blah. Okay, so the book just leaves it as cosine of 2. They don't actually evaluate it in radians or degrees. They just leave it as cosine of 2, which is fine. I will let you do that. That's okay with me. I don't care.
Yay.
I don't
Those are
care.
yucky numbers.
Okay, good. All right, so the same thing applies to like sine, cosine. You can still do the factor out and cross stuff out method. Okay. Now, the next thing, I don't think I asked you any questions on this, but I'm just going to introduce this and show you that this is a thing that you can do. So let's say I'm trying to find the limit of something that is very hard to evaluate. Are you listening?
Yes, yes.
I'm trying to find the limit of something that's very hard to evaluate, okay? What I can do is, if it's very hard to evaluate, I can find something that, a function that has a limit that's higher than it, a function that has a limit that's lower than it, and use it to squeeze it in to find the limit of what I'm trying to find. Does that make sense? So a similar function, finding the limits and then squeezing it in, okay? So that was kind of like yesterday where we said with the intermediate value theorem, if I have something that's up high and something that's down low, I can find where he's going to cross in the middle, and I can find it closer if I keep pinching it in, right? That's kind of like the squeeze theorem, but using limits. The squeeze theorem uses limits instead of using the intermediate value theorem where we're using values, okay? I'm not going to elaborate too much on that. It's kind of a confusing concept, so I'm going to keep going on. Okay, I don't think I give you any squeeze theorem stuff, okay? Example 3 is the last piece. This is it, folks. A is this guy right here. They want us to find the sine of 1 over x, which is the graph of that, as x goes to 0.
Does not exist.
Because he doesn't go to
It
0.
goes
Do
to
you see what's happening?
He stops at 1.
What's happening at 0?
Ah.
There's a va, right? Even though it's inside of sine, there's going to be a va here. You can't have 0, right? And 0 is going to be a va. He's going to like oscillate. And I think he oscillates forever also, right? But the limit's going to be it does not exist. Okay, you can look at the graph and see that it's oscillating, or you can look at the function before you take sine of it and say, oh, there's a vertical asymptote there before we take the sine. So the limit's going to not exist. Over here, this one's kind of interesting, okay? This is something called a damped function, not the other word. It is a damped.
D-A-M-P.
There's a D-A-M-P-E-D, okay? Not an N, okay? D-A-M-P-E-D. It's a damped function. So we have two functions. We have an x and then we have a sine, and this is a damped function. The graph of x, if we do the absolute value, he goes this way and he goes this way. They do the absolute value. I don't know why. That's just how it works in the graphing world, okay? So x is a linear function. He goes that way, and the sine is going to oscillate between those two values. So it's going to keep going up and up forever, which is kind of a fun little thing. It's kind of interesting, okay? As he gets towards 0, what is your coordinate going to approach, or what's your y value going to approach?
0.
He does approach 0, right? He's going to oscillate, but he's getting smaller as he oscillates towards 0. So that one does have a value of 0 by looking at the graph. Yeah, he's moving toward the origin. Yeah,
Okay.
that's all. So here's the homework assignment for that. Okay, start working through those, and then we'll go over some questions on Monday. Okay,
Alright, coming.
there you are.
Hey,
That is all. Goodbye, Jalen.